Hello everyone, I'm Thomas and welcome to my web development, cloud and IoT education channel. Today I'm gonna show you the simplest method to connect your ESP32 to the Wi-Fi network in a blocking and non-blocking way using Visual Studio Code, PlatformIO and Arduino framework. Let's get started. First of all, let's make sure we have all the tools required to do the job. So what we need is ESP32 development board. I suggest using one of the most popular that you can find on Amazon or AliExpress, like Node MCU 32S, the one that I'm using. Apart from the board, you're gonna need USB to micro USB cable to connect the board to the computer. And in terms of software, we need Visual Studio Code with PlatformIO extension. And for the details regarding setting up the board, choosing the right cable, installing Visual Studio Code, or installing additional drivers that might be required for Windows and Mac users, I'd like to recommend one of my previous videos called Getting Started with ESP32. You can find the link in the description. Right, and now let's create a new project in Visual Studio Code. So here I am on my computer. Let's create a new project with PlatformIO. So the first step is to locate PlatformIO icon. It's this one over here. I'm going to click on it. Then from the quick access menu, I'm gonna click on open. Then I'm gonna close this quick access menu by clicking on the PlatformIO icon again to make some space over here. Then on the new project from this quick access, for the project name, I'm going to pick something like ESP32 Wi-Fi Connect. The board is the board that I'm using, which is Node MCU. So I'm gonna start typing Node MCU. And there we go. We've got Node MCU 32S. That's the one I'm using. Framework, I'm going to keep Arduino, and location is gonna be default location. So now I'm gonna go ahead and click on finish. And after a few seconds, I should have my project created, and there's gonna be few tabs opened automatically, like get started, and in a few seconds I should see platformio.ini and PlatformIO home. Actually, get started tab has been closed automatically. Right, and what we've got here is the main configuration file of our project that I'm going to modify in a second, but before I do that, I'm going to open main.cpp. That's the file where we're going to keep all our code. So this is where I'm gonna write the code to connect to Wi-Fi. This is a Arduino framework program structure, right? We've got a setup function. This one is executed only once at the beginning, and the loop function that is gonna be executed repeatedly. Okay, let's go back to platformio.ini and let's set up a serial communication so we can see the messages sent from the microcontroller printed out on the screen in a serial monitor here in Visual Studio Code. Okay, in order to do that, I'm gonna add monitor speed, and I'm going to set it to 921600. That's gonna be the value that I'm going to copy and paste it into serial.begin. So that initializes the serial communication. Okay, so that's the first step of a setup. The second one is going to be setting the pin mode on a built-in diode. Gonna change it to output, so we're gonna take control over the voltage that is sent to this diode, and we're going to use this diode as a status indicator, right? As the blue diode on the development board. And what I want to do is to switch this on when we have a Wi-Fi connection and switch it off when we don't have Wi-Fi connection. And now the third step of an initial setup is going to be to define two constants. The first one is gonna be Wi-Fi SSID. And the second constant Wi-Fi password. These are the Wi-Fi network credentials. Let me just explain. Let me just provide the value and I'm gonna explain. So SSID is the name of the Wi-Fi network that you want to connect to. And the password is basically the password to this Wi-Fi. I'm gonna keep these values as a constant so I can pass them to a relevant method to connect to Wi-Fi. Okay, so the initial setup is done. Now let me show you how to connect to Wi-Fi using the blocking method. So what we need first is to include Wi-Fi multi.h. This is the library that is built on top of the core Wi-Fi library of ESP32 on Arduino framework. And this one requires creating an instance of a Wi-Fi multi. So that's what I'm gonna do just now. So we're going to create it and assign it to Wi-Fi multi variable. And once I have just done that, what I need to do is to call a method on this Wi-Fi multi instance. That method is called addAP. That means add access point. It requires two arguments. The first one is SSID. That's the name of the Wi-Fi. So I'm just going to pass the constant value, the one that we defined in here, right? Wi-Fi SSID. The second argument is Wi-Fi password. Okay. This library actually allows for specifying multiple access points. So it is more resilient. Basically, what you can do is to specify 3 of them, right? If you have 3 access points. And if an attempt to connect to the first one fails, it tries the second one, right? Then if the second one fails, it tries the third one, right? So it's gonna keep trying until it connects to one of the access points added to this Wi-Fi multi. But because I have only one access point, I'm just gonna keep this like I've got it, right? So just Wi-Fi SSID and Wi-Fi password. Okay, and now after adding access point, this is the actual blocking code. That's gonna be a while loop with Wi-Fi multi again, but this time a run method. That result we checking against WL connected, right? So we compare if the result of Wi-Fi multi.run, a run method, is different than WL connected. And if it is, we're gonna do a small delay of 100 milliseconds, and that loop is just gonna keep trying, right? Keep executing this Wi-Fi multi-run until the result of it is WL connected. That means we are connected, right? And this is the blocking part, because no code is gonna be executed after this while loop until the board, the microcontroller, actually connects to Wi-Fi, right? And this is why I'm gonna add a serial println connected, right? So when we are connected, the program's gonna exit this loop, and then this line is gonna be executed to tell us that we are connected. And finally, we can do a simple trick in a loop function with digital write to use the built-in diode as a status indicator. So let me just provide this, the first argument, which is the LED built-in, and the second argument is gonna be something new here. So I'm gonna use the core Wi-Fi instance status. I have access to it because Wi-Fi multi is built on top of it, so I can actually access methods on Wi-Fi straight away. And I'm gonna check if that status is connected. So basically what this is gonna do is continuously check if the Wi-Fi status is connected. And if it is connected, the result of this comparison is gonna be 1. So the diode will switch on. if the status is not connected, let's say we connect at the beginning, but then the connection drops for some reason, right? Let's say we move away from the router and the board cannot reach our router, the connection drops, and the result of this comparison is gonna be false. This is 0, the diode should switch off. One thing to note though is when we move closer again, for example, the Wi-Fi multi is gonna take care of reconnecting to Wi-Fi. So we should see the diode on after a few seconds because it's just gonna try to connect, and if it succeeds, we will see the diode on. Okay, let's see if this code works, and then let's move to the non-blocking way. Right, so in order to deploy this code, first we want to make sure that our development board is connected to the computer using USB cable. And once we make sure it is, we can just click on this button, the arrow button here, PlatformIO upload. So that's what I'm gonna do just now. And we should see a compiling message over here because it compiles all of the code. Okay, the code compiled, and now we've got connecting. And when it is connecting, it is important to press the boot button on the board and hold it. Right, okay, now we can release the button because it's deploying the code to the board. And there we go, everything deployed. We can check the serial monitor now. It's this button over here, serial monitor. So I'm gonna click on it. That should connect automatically, but you may see something like I see. And then what you are interested in is this bit where you can find CP2102. That's the name of the driver used for the serial communication. So in my case, this is number 3. I'm just gonna type 3 and enter. And after a few seconds, we should see a connected message and the blue diode should be switched on. Right, so that was the blocking way. Let me show you the non-blocking way now. Okay, what I'm gonna do is to just remove Wi-Fi multi-code, and we're going to use something else. And that something else is the core Wi-Fi class of ESP32 and Arduino framework, which is in a Wi-Fi.h. This is actually what the Wi-Fi multi has been built on top of, but we're going to use the core functionalities. So by including this Wi-Fi.h, I have access now to a Wi-Fi instance, and on this Wi-Fi instance, I can call a begin method. That method requires SSID again, Wi-Fi SSID, and Wi-Fi password. This is how to initialize the Wi-Fi connection. This is not blocking, so after that you can execute the code if you want. So we could do something like starting, something like this, and then we can also execute the code in the loop function. And this is where I'm going to write all the behavior of this program, which is going to be slightly different to the previous one, because what I want to do is to blink this blue LED diode when the controller is connecting to Wi-Fi, and then just kept it switched on when it is connected, right? When the connection drops, I want again for the LED diode to blink. So that's gonna be the behavior, and let me just program it. So what we need to do is to use Wi-Fi.status, a status method, then we can check if it's connected. And if it is connected, we can, for example, print out connected message. We can do the digital write to change the built-in diode, the blue one, right, to high, so switch it on. And if it's not connected, I'm gonna explain why I'm doing it in a 2 if statements in a second. When it is not connected, what I'm going to do instead is to print a dot that's gonna indicate that it's connecting. And then I'm going to blink the diode in the most efficient way. And that most efficient way to blink the diode is to, again, use the LED built in as a pin. But as the value, what we're going to do is to use the opposite value of the digital read of LED built in. So basically what it does, it reads the voltage of a built-in LED and returns it and then turns this value around, right? So if it's high, then we're gonna get low here. If it's low, then we're gonna get high, right? So that's what's gonna make the diode blink. But apart from this, we also need a delay, right? So there's gonna be 1 second delay for the blinking itself. Okay, so now we have 2 contradictory if statements, right? If this is happening, this is not happening. But there is one piece missing, which is on the transition of the state. So basically, we don't really want to have a situation when we have a Wi-Fi connected to run this code every single time, right? We just want to run it once when we have a connection. The first time the status changes to WL connected, we want to execute this code, and that's it. We don't want to execute it again unless the connection drops. Then we're gonna go back to this, but that's gonna happen anyway, so it's gonna blink. When we have the connection back, I want this code to be executed only once on a transition of the state, only when the status changes from not connected to connected. So what I have to do to achieve this and not see, like, you know, millions of connected messages in the serial monitor is to add additional flag in here. So that's gonna be a Boolean variable that I'm going to set to false as a default, that I'm going to check if it's not true, and that I'm going to check to change to true once the diode is on and the message is printed out. And also change to false when the connection drops. Let me explain this again step by step. So after the initialization of the serial, the built-in LED, and the Wi-Fi, what's happening is we've got this loop function that is executed continuously. The board is trying to connect, and we check the status. If the status is not connected, this is what's gonna happen at the beginning. We're just gonna keep printing dots, and we're going to keep blinking the diode. This flag is gonna remain false. The moment we have a transition of state, so the status changes from not connected to connected, because the is connected flag is false, this code is gonna be executed. So the connect is gonna be printed out, the diode is gonna change to high, it's gonna be switched on, and is connected is gonna change to true. The next call of the loop, because the is connected is gonna be set to true, this code won't execute again unless we, for example, move away from the router, the connection drops, we have the transition of the state of a Wi-Fi from connected to not connected, then what's gonna happen? This code is gonna be executed again, right? So we'll see the dot, we will see the diode switching off, delay, we're going to have a connected to false, and that's gonna continue until it is connected again. And this is the moment where we, again, just once print out connected, change the diode to switched on, and again setting the flag to true. Okay, So that's finished essentially, and let me deploy this code now and let's test this solution. So yeah, again, make sure your board is connected to the computer, and then what we need to do is to click on upload, and once we see connecting message connecting here, we need to press the boot button on the board and hold it, and now we can release it, and that code should be deployed quickly. Right, so I can now see this diode blinking. Let me connect to the serial monitor. Okay, there we go. We can see starting, then 3 dots. I could see the diode blinking and we have connected. Again, a simple experiment that we can do is to connect the board to the power bank, move away from the router until connection drops. When it drops, it should start blinking. Then we should move back closer to the router and we should see the diode on. That indicates it's connected back. And this is it for today. Now with these two methods of connecting ESP32 to Wi-Fi, we have a nice template that I can reuse in any Wi-Fi based project that I'm gonna build in the future. Thanks for watching. If you find this content useful, don't forget to subscribe to my channel. If there is a subject you would like me to make a video about, let me know in the comments. Cheers, bye.